So this lesson is on solving exponential equations. And so there's two different approaches you can take with solving exponential equations. Sometimes you must use logarithms to solve exponential equations, but there are times when you don't have to. So this first bullet says to write each side of the equation with the same base if possible. Then you're going to set the exponents equal. So if we look at example 1a, we can do that. We can write both sides of this equation with a base of e. And so the left side is already written with a base of e raised to the x minus 2. And then the right side, we can write 1 over e to the 5th as e to some power. And we've talked about this a few times the last couple of weeks. But whenever you have a negative exponent, it does the reciprocal. It moves whatever it is to the denominator. And so 1 over e to the 5th is the same as e to the negative 5th. All right, so if you can do that, this is definitely quicker than doing it the other way, but it's kind of rare that you actually get to do it this way. Anyway, once you write them with the same base, then you're just going to set the exponents equal to each other. So if e to the x minus 2 is equal to e to the negative 5, then that means those exponents must be equal. So you can set them equal to each other and then solve it for x by adding 2. All right. And then you get a number that you can plug in for x and get a true statement. So it would be e to the negative 3 minus 2 is equal to 1 over e to the 5th, which is true, because that would be e to the negative 5 is equal to 1 over e to the 5th. And that's the absolute definition of a negative exponent. All right, so let's look at the next one. So can we write 4 and 5 as some number with the same base? Like 4 to this a power can give you 4, and 4 to some power can give you 5. And that's not possible within this situation with the 4 and the 5. So we're going to have to do this the other way. And so the other option is, if you cannot write with the same base, then what you want to do is isolate the exponential expression. And in this case, on example B, that has already happened. So the exponential expression is 4 raised to the x plus 7. So that's already isolated, so we don't need to worry about that step. We're ready to do the second step, which is to write in logarithmic form. All right, so when we're writing this in logarithmic form, we can do the loop if you want to, but it would be log base 4 of 5 is equal to x plus 7. All right, and then we can use our calculator to figure out what log base 4 of 5 is. So we'll do alpha, window, and then choose number 5, and we'll type in log base 4 of 5. All right, and then I'll just go to about 3 decimal places. All right. And then to solve that, I'm just going to subtract 7. And so I would just leave that big long decimal in the calculator and just do minus 7. All right, and then we can round that also to 3 decimal places. So our answer is going to be negative 5.839. That is approximately what x is. Now, on these types of equations, you're not going to get an extraneous solution, but it's still not a terrible idea to check your answer. And so we would want to see that if I took 4 and I raised it to the negative 5.839 plus 7, we should get approximately 5. We're not going to get exactly 5, but we're going to get something close. All right, so we did that one right. All right, let's look at the next one. Okay, so on this one, I do need to do the first step, which is to isolate the exponential expression. So my exponential expression in this case is going to be e to the x. So the first thing I would do is move that 7 to the other side by subtracting it. Then I would divide by -2. So you can leave that 3 halves, or you can make it 1.5, whatever you want to do, whatever is easier for you. All right, and then we want to write this in logarithmic form. And this time the base is e. So anytime the base is e, that's going to be the natural log of 1.5 is equal to x. All right, and then we can find out what the natural log of 1.5 is in the calculator. For natural log, we can just use the button beside 4. All right, so our answer is going to be approximately 0.405. And then if you wanted to check that, we could do 7 minus 2. E is going to be second ln to the 0.405. And see if we get something close to 4, and we do. Okay, let's look at D. On D, we are going to need to isolate the exponential expression by dividing by 4. All right, and then because I can't write 12 as an exact power of 3, we're going to have to use logarithm. So we would write this in logarithmic form. Log base 3 of 12 is equal to x. And then we can figure out what log base 3 of 12 is. So we're going to get approximately 2.262. Okay, we're going to do a couple more, and then you guys are going to have some to do on your own. All right, so our exponential expression this time is going to be 2 to the x. So we would just follow the rules of algebra to get that isolated by adding 3. And then dividing by 5. All right, and then this is another situation where we need to write it in logarithmic form. So log base 2 of 3 equals x. And then we can figure out what log base 2 of 3 is. All right, and then this last one, that whole thing right there is our exponential expression. So the first thing we need to do to isolate it is just to subtract that one. And that's actually the only thing we need to do to isolate it. All right, and then we're going to write this in logarithmic form. All right, and then we have two things we need to do to solve this for x. The first is to subtract 4. And the second is to divide by 2. And we get an approximate answer for x. All right, so what I need you guys to do for the rest of the class period is work on the back side of this, which is 1 through 8 solving exponential equations. Some of them are going to be like the first example, and the rest of them will be like all the others.